In this clip, I will present some general features of water and of the porous medium across which it flows. Several aspects are similar to what we have already discussed for hydrocarbons, but there is also some important differences. This is what a water molecule looks like. You clearly see the oxygen and the hydrogen atoms. You also see that as a consequence of their asymmetric arrangement, the water molecule has a positive and a negative end. A very important property of water is its density, which is around 1 gram per cubic centimeter. At temperatures relevant for hydrogeology, these values don't change much. Things are different, however, at high temperatures, and for instance at 60 degrees, the density of water is 0.97 gram per centimeter cube, which is a big enough difference to cause vertical movements in the thermal system. Let me show you immediately an example of the importance of heating. When cold water descends towards deeper level, it will be heated and it will then start moving upward because of decrease in density. If the permeable layer is sealed by an impermeable one, then convection cells are generated. If faults are present, then the hot water can travel along the related fracture zones and possibly reaching the surface, forming high temperature springs. The density values we have mentioned are for pure water. When this is not the case, things are different. In a previous clip, we've discussed turbidites, currents which travel for hundreds of kilometers down the continental slope, driven by their density higher than the surrounding water. An effect of density contrast is also seen in coastal regions where fresh, low-density water from the continent overlies a tongue of denser saline water from the sea. As we will see at a later stage, preventing the continentward displacement of salty water is a major challenge in these coastal domains. Another important property of water is viscosity, which is a kind of internal fraction of the fluid resisting its flow. In a more precise manner, it can be defined as the parameter mu in the equation, which describes the force needed to keep the upper plate moving with respect to the lower one. Values are clearly much less than those of oil, and on the whole, clean water has no big problem in flowing, especially at the rates relevant for hydrogeology. Water flows through a pores of a medium, which can be everything between loose sediment and a real rock. In these cases, surface tension and capillary forces are important. Because water molecules are attracted to each other, they form a superficial resistant layer aptly used, among others, by insects. In contact with the glass surface, water does not spread homogeneously and forms a bubble, this being also an effect of the surface tension. In average type of rocks, things are different, and water spreads easily, forming a thin film of fairly homogeneous thickness over all grains between 0.1 and 0.5 micromillimeters. This seems not much, but it means that grains will be water wet even if the rock is well above the water table. It means also that some of the smaller pores between the grains will be occluded by water, holding the grains together. Children or adults alike, building castles on the beach know very well how to exploit capillary effects to improve their building and achieve steep walls. The porosity in a sediment or rock exerts a fundamental control on the ability of a fluid flow to through it. We've seen in Module 5 that the main features control porosity and permeability. In granular rocks, porosity is the space between the grains and depends on the grain size and the degree of sorting. A very important source of porosity and permeability is also provided by fracture networks. These are particularly relevant for deep reservoirs targeted by geothermal projects. A last important issue I would like to mention at this stage concerns the interaction between the flowing fluid and the surrounding rock. At the mechanical level, infiltration of water in mechanical discontinuities can destabilize, for instance, mountain flanks, triggering landslides. Interesting are also the chemical interaction between the water and the surrounding rocks. Waters are typically carrying varied ions and cations, and the appropriate conditions can start precipitating minerals such as calcite. This is a very important phenomenon impacting, for instance, the permeability of faults. On the other side, waters can also dissolve the surrounding rock. This is especially the case for carbonates, resulting in spectacular karst structure and large underground caves.